Hello, welcome to the notes on 2.3 slopes of lines. This should be a review, many of you, from Algebra 1. There are a couple different ways to talk about slope. Slope is considered the rise, the vertical change, up and down, over the run, the horizontal change, left and right. There's a formula when you have two ordered pairs, x1, y1, x2, y2. It's y2 minus y1 over x2 minus x1. This third one here, this little triangle, that is the Greek letter. It's delta, and delta means change in. So it's change in y over change in x. And then we also could refer to slope as the rate of change. In fact, many times when you have word problems, instead of them asking you what is the slope, they're going to say what is the rate of change. So how many miles per gallon, how many dollars per hour. That is a slope. It's a rate that something is changing. So when you look at a line that is graphed, you can classify slope as being positive, negative, zero slope, or undefined slope. So I remember when I first started teaching, I would say, oh, the line is going up. That means it's positive. And then I had students saying, well, isn't it going down right there? And I thought, you are right, it is. So I started telling students, you have to look at the line left to right the way we read. Okay, so you're always going to be looking from left to right. If I was walking along this first line here, I would be going up. Going up means positive slope. Right over here, if I came across this line, this would be very hard to walk down because it's very steep, but going down left to right, that's a negative slope. Our third line here is a horizontal line. That's going to have a zero slope. If I was walking along, this is my favorite type of line to walk across because I don't have to go uphill, I don't have to go downhill, means I don't have to exert extra energy. So therefore, it's a zero slope. There's no slope involved. And I could use part of the line here if you forget whether it's zero or undefined. I could use a part of the line to do the z for zero. So that is a zero slope. And the last one here is a vertical line. If I was to try to walk along, this would be, this is not possible for me to walk along. That was my body, legs and arms. You can't do it. That's undefined. You can use a part of the line to kind of do the U for undefined. So again, horizontal lines have slope that equals zero. Zero is a number. Vertical lines have slope that's undefined. It's infinitely large. Okay? So if I was to determine the slope of these lines, so here I have two ordered pairs. One of them is x1, y1, the other one's x2, y2. Which is which doesn't matter. So if I call this x1, y1, and the second one x2, y2, I'm going to find the slope. The slope is going to be y2, negative 1, minus y1, negative 5, over 4 minus negative 6. Obviously, I'm going to clean this up. Negative 1 plus 5 is positive 4, over 4 plus 6 is 10. Always, always, always reduce your answers. This is going to equal 2/5 once I reduce that slope. So I'm going to do this problem one more time, but I'm going to switch my ordered pairs. So I'm going to call this one x2, y2. And then this one, x1, y1. Okay, so the slope here would be y2, negative 5, minus y1, which is negative 1, over negative 6 minus 4. Again, I have to clean this up. I would end up with negative 4, because that's what negative 5 plus positive 1 is, over negative 10. Please don't forget that a negative over a negative, that will always simplify to be a positive, and that is 2 over 5. On a side note, that reminds me, if I ever get an answer that's, say, for example, negative 1/10, and the negative's out in front, that is the same thing as negative 1 over positive 10, which is the same thing as 1 over negative 10. As long as you only have one negative sign, all three of those are the same. They're equivalent. A negative over negative, we always want to write as a positive. Okay, let's try this one. So we're going to do the slope, and I take one of the y's. Say I start with 2, I'm going to subtract negative 9 over negative 5 minus negative 5. This is going to equal 11 over 0. Now, if you are dividing by 0, you have to simplify this, or if 0 is in your numerator. Regardless, you never want to leave a 0 in your answer and just say, okay, I'm done with this problem. When you divide by 0, you get an answer that is undefined, and that's how we're going to show undefined. And the reason that that works, or a way to try to remember, especially if you don't have a calculator, if I do something basic like 10 divided by 2, what I'm doing is undoing multiplication. So I'm saying 2 times what number would equal 10? That answer is 5. So here, 0 times what number would equal 11? That number doesn't exist. There is no such thing. If you try to divide by 0 on your calculator, it's going to tell you error because it doesn't exist. It's undefined. And the last problem here, we're going to find the slope of LM. LM is graphed for us. So we could either, write that this is 1 comma negative 3, and then L is at negative 2, positive 3, or do rise over run. Count. How much would you go up? That's going to be a positive direction. How much would you go to the left? That's a negative direction. Alternatively, what you could do, or alternatively, you would go down, which is a negative direction, and then positively to the right. That's a positive direction. Either way, you are going to get the same answer. So go ahead, count that, and tell me what you get as the slope. And that gives us the slope of negative 2. Make sure you always reduce, and then check. The line's going down, the slope should be negative, so this answer should make sense. So now let's get into parallel and perpendicular slopes. So lines that are parallel, they're never going to intersect each other, and the reason that happens is because they have the same slope. If they had different slopes, they would eventually intersect. Perpendicular lines have opposite reciprocal slopes. So if you were to take them and multiply them together, the product is always going to be negative 1. So I know some 8th grade teachers, I've had students in the past, said that their teachers called it the flopposite. So you flop, like you flip it, and then flopposite. So the opposite sign. So if one's positive, the other one's negative, and vice versa. So here's an interesting note. A horizontal and vertical line are perpendicular, but their slopes are not opposite reciprocals, because a horizontal line has a slope of 0, a vertical line is undefined. But a vertical and horizontal line are always going to intersect and be perpendicular each and every single time. All right, so here we have our first example. We're going to figure out if FG and HJ are parallel, perpendicular, or neither. So we're given points, the points FG, H, and J. So what I have to do is I have to find the slope of each of these. So first I'm going to find the slope of FG. Now a lot of times kids will find the slope of FG and then say yes. I'm like, that's not really answering the question. Sorry, this is a little messy. FG. So I start with one of the y's, it doesn't matter which one, and I subtract away the other y. So negative 3 minus negative 1 over, and then because I started with negative 3, I have to start with 1. It's going to be minus negative 2. Okay, let's clean this up. Negative 3 plus 1 is negative 2 divided by negative 1 minus negative 2 ends up being plus, and that gives me 3. All right, right now, this doesn't tell me anything. All it tells me is the slope of FG. So I have to do the same thing for HJ. All right, so for HJ, let's look at these 2 points, and it doesn't matter which y I start with. If I start with 0, I'm going to do 0 minus 3 over, and then because I started with 0, I have to start with 5 minus 6. This gives me negative 3 over negative 1. Always simplify, negative over negative is a positive 3. So I compare negative 2/3 and positive 3. If they were the same, they'd be parallel. If they were opposite reciprocals, they would be perpendicular. These are neither, okay? Because negative 2/3 does not equal 3, and it's not the opposite reciprocal of 3, so they're neither. They're lines that are just going to intersect somehow, but not perpendicular and not parallel. All right, so now we're going to graph the line with the slope of negative 1/4 that passes through the point negative 3, 2. So always start with the point that you're given and graph that. So negative 3, positive 2 is right here. And then a negative slope, remember, slope is rise, your up and down change over your left and right change. If I have negative 1/4 as my slope, remember that's the same thing as negative out in front or negative in the denominator. So I have a few choices of how to do this. But all the while, I'm thinking to myself, I'm already picturing what this line is going to look like. It's going to be going down left to right. So I know that that's what my line has to look like. So from this point, -3, +2, if I go up 1, I have to go to the left 1, 2, 3, 4. Now I'm not going to go up and left again because I ran out of grid. So I'm going to go down 1 and right 1, 2, 3, 1, 2, 3, 4. I could go down 1, 2, 3, 4 to the right. Connect it, and that is my line. So if I need at least 3 points, my first point was given. Over here I'm at 1, 1, and over here I'm at 5, 0. This point over here, I went to the right 4, so I'm at -7, and up 1, so I'm at 3. Okay, and that's how we graph that line. All right, so what is the slope of the line perpendicular to MN with M equals 1,6 and N is at -2,5? So what I want you to do is find the slope here of MN of this line. You're gonna have to find that slope first and then tell me what the perpendicular line slope is. All right, here's our perpendicular slope. You should have gotten -3/11 after finding the slope of MN and then taking the opposite reciprocal. Because remember, perpendicular lines is the opposite reciprocal slope. If you did not get that as your answer, make sure to ask your teacher in class. All right, so here's a very, very popular type of problem that shows up in slope sections. We're going to find the value of the variable that satisfies the following conditions. So we have a line that goes through -3, -5, and 6y. So notice we are missing a variable here, but we know what the slope is. So we are still going to set up a slope formula, except now I know that the slope is -5. Okay, so I know what it's going to equal. So I like to always start with the ordered pair that's missing the variable. Like I could start with -5 or I could start with y. I'm going to start with the ordered pair that has the missing variable. So it's going to be y minus -5 over, because I started with y, I have to start with 6 minus -3. And then I like to put this over 1 because our slope is -5. If it was 5/7, I would just say equals 5/7. So now I'm going to go ahead and clean up. So I'm going to go over here. I'm going to clean up the left side. This is going to be y plus 5 over 6 minus -3 is 9, and this is going to equal -5 over 1. Now we can multiply both sides by 9, or you could cross multiply, especially if your slope was a fraction. Ours wasn't. It was an integer. It was -5. But if it was a fraction, I would say probably cross multiplying would be a good idea. So I do 1 times y plus 5 is going to equal, and then multiply the other numerator and denominator, and we get -45. Distributing here, because it's just a 1, it doesn't change my value. It's y plus 5 equals -45. Y is going to equal -50. If you're not sure if your answer is correct, remember, if y is -50, you could plug this back in and find the slope of this line. -5 minus -50 over -3 minus 6. This is going to equal, sorry, this is also squished, 45 over -9. 45 over -9 does give me a slope that's -5. So I could be confident that I found the right value for y. Okay, so this last one kind of combines two ideas. We want to find the variable that satisfies the following condition. The line that contains -1, -2, and 3, -4 is perpendicular to the line containing 1, -6, and x2. So this is kind of a two-parter. This line that we have two values for, we know is perpendicular to a line that we are missing the value for. So the first thing I'm going to do is find the slope of this line. So -2 minus -4 over -1 minus 3. This is going to equal 2 over -4, so -0.5. All right, but my line is perpendicular to this one. So the perpendicular slope is the flopposite, the opposite reciprocal. So it's going to be 2. Now I take this 2 and I'm going to use it with these 2 points and do what we did in the previous problem. So I set up a proportion. I know this equals 2, and I'll put it over 1. Now, I like to start with the ordered pair where my variable is. So I'm going to start with 2 minus negative 6, and put that over x minus 1. Clean up the left side. It's going to be 8 over x minus 1 equals 2 over 1. Now let's cross multiply. 2 times x minus 1 equals 8. I get 2x minus 2 equals 8. Add 2 to both sides. You get 2x equals 10. Divide by 2, x is going to equal 5. Okay, and if you aren't sure if that's correct, always plug it back in. Make sure that it works out in the original order pairs if you plug in your missing variable. All right, so that's it for this lesson on slope. Hopefully a lot of this was a review from Algebra 1. In class, you're going to be working on 2.3 practice. Thanks so much for watching. Have a great day. Bye.